Let's continue. Chapter 3. Today we will conclude chapter 3 and then we'll go into chapter 4. I want to highlight 3.5, conservation of force and potential energy. How you know that you have a conservative case and non-conservative case. For forces, conservative force, if the work of the force is independent of the path, depend only on the force initial and final position, then we have a conservative forces. Okay. What is work? Please work. Force from the distance, but these two are vector, they must be parallel. So in the statement here, conservative, it means force that independent of the path. Let's say you have a particles on object. This is force. And no matter how this object moves, at the end, it reach position 1 to position 2. In this case, this force is conservative. Okay, so example is a weight of particles when it's going down, no matter how it's swing to left or right, but we're only interested in beginning and end. Then another one is a spring. No matter how you charge it up, it will also give you either elongation or compression. And I give you friction of force is not conservative. Why? Because the friction force is dependent on the path that it travels. The longer the distance friction travel, the greater the work. Okay, so remember this conservation of force. Okay, then on the potential energy, I want to highlight it always dependent on the datum that you see in the question, or you can set the datum yourself. Of course, if the question already give you datum, don't go and change the datum. Okay, so as long as your object above the datum, you have a positive mgh or wy. If the object starting from below, then you have a negative mgh at the beginning. Okay, depending on the datum. For spring, you always have a positive energy, spring energy, right? So half ks squared, right? Always positive. So potential energy, you have two types. One is based on datum or gravitational force. Another one is on a spring. So you have two. So every time you see the question asks you to calculate potential energy or conservation of force and energy, remember to check whether you have a spring or datum. Okay, so I'll also give you some example. This example is a spring with the particles. So these particles is below datum, so it's negative mgh plus the spring is always positive. Okay, so this is a potential energy. All right. Okay. Then for the three-dimensional, this one you read. All right, three-dimensional is a derivation of your f dx, f dy, f dz, and then it will come into partial differential, which is inverted triangular multiplied by the v. Okay. So principle of work and energy, you can write, if the question asks you to use principle of work and energy, you can write as T1 V1 plus conservative work, non-conservative work plus the energy at the end station. Okay. All right. So if only conservative work does work, means no friction, then you use this one. Okay. If only conservative work, you see the question, a skater on the ice, a car on the wet road, or say something, you see something smooth surface, then straight away you modify the principle of work and energy equation, remove the non-conservative work, then you arrive at T1 plus V1 equal to T2 plus V2. T is kinetic, V is potential energy. As long as the particle move with the velocity, then you sure will have kinetic, because half mv squared. Potential, you have two things. Potential, you need to look at gravitational datum, and spring. You have two things here. If you don't have spring, then you remove spring. Okay. All right. So if the question, look carefully, the question either asks you to use principle of energy or conservative of energy. So if you see the question use conservation of energy, then straight away write this equation. Okay. Right. Now, if the question asks you to do conservation of energy, although there's a friction, you still write this one. Means you assume there's no friction in your calculation. You remove or you ignore the friction force in your calculation. Principle of work and energy. Look carefully. The question either you will mention based on your understanding in principle of work and energy, then you use this one. Then maybe the second part of the question, use conservation of energy in your solution, then you use this one. Okay. So they prove the potential energy, kinetic energy based on position and also velocity, right? We already proved that there's no change of energy. Right. Okay. We already proved. So this one, if you're not familiar, go home and read. So if you have a set of particles, you will see this one when you come to rigid body. We are now still at particles. So particles, we assume everything acting on one center of mass. We'll sum everything in one, although maybe this one is one person, but we still assume all the mass is acting on the center of gravity. Okay, let's look at this example. A gangly structure we use to test the response of aircraft. So this aircraft was tied to a rope in datum, right? And then the end of the A here was tied to C. Again, you see the question got gain datum. It's actually a hint. When you see your datum, it's actually linked to potential energy already. You see datum is either datum only you see in two kind of question. One is pulley. One is pulley system. Something like that. Okay. One is pulley system with datum. Something like that. Okay. Pulley system, you have datum, or potential energy will give you datum. Right. Okay. All right. So the plane having mass 8 megagram. You will see this kind of format in your test or final exam. Remember to change megagram into kilogram. Okay, you're using unit SI. It's very famous. We always like to give you megagram or give you ton. 1 ton equal to 1,000 kilogram. Okay, it's hoist back until theta equal to 60 degree. Where is theta? Theta is here. Then the pullback cable AC release when the plane is at rest. So you have velocity. Okay, you have angle. You have datum. You have velocity. You have the length of the rope. Okay. Now, before you go further, you look at the question, you can roughly guess what actually the question trying to do. You look at the particles. Once you cut the cable AC, how's the object move? It move in a straight line or curvature line? Curvature. So it's fall under collinear motion. Collinear motion, straight away draw tangent and normal direction. Okay. And collinear motion, you have normal direction, tangent direction. Collinear motion, most of the time, it want you to find AT and AN. How to find AN? V square over rho. How to find AT? How to find AT? What is the definition of acceleration? dv dt. How to find rho? There's the equation there. Rho equal to something differentiate, something differentiate. That one. Okay. So of course, this question already give you the rho, so you don't need to care about this one. All right. So it asks you, determine the speed of the plane just before it crashed into the ground at 15 degree. Also, what is the maximum tension developed to support the cable during the motion? Tension is what? Tension is force. Tension is force. So you have force, you have velocity, you have a curvature motion. And all. Okay, ignore the size of airplane. The effect of lift caused by the wing, you can ignore. Okay. So you look at this question, this is how you know it's chapter 3 question. All right. So of course you can solve by chapter 2 question. By using F equal to MA. Or you can use F equal to MA, but using normal tangent direction. Or you can use conservation of energy, principle of work and energy to solve these problems. Okay, so there's no, this example 8, there's no one method to solve, but in the exam, you will be directed to use a certain method. You will be forced to use a certain method in the question. So you need to determine the speed when it's at 15 degree. Okay, now no matter it's chapter 1, chapter 2, chapter 3, or chapter 4, or even chapter 8 question, first step is to draw free body diagram. So you have to understand what is the object, what is your focus. Is it cable or is it something, right? So this is dynamic, engine dynamic. So you're focusing on the object. So draw the object first. Okay, all right. Okay. So since the force of the cable does no work on a plane, the cable doesn't do any work. Why? Why cable doesn't do any work? Why? Why? Work and displacement is what? Not parallel, but they are what? perpendicular. What is work definition? Work equal to force multiplied by distance. They must be parallel. In what case there is no work? When your force and distance are force and displacement, they are perpendicular. There's no work. If you are aircraft, this is a cable. You always tie perpendicular to the distance. So no work. So if no work, then you can use equation of motion, F equal to ma. So first, however, we must determine the plane speed at B. Okay. So you draw the plane. Of course, in a test, you don't need to copy the shape. As long as you draw a rectangular, you draw something lah. As long as draw a rectangular, you want to use ellipse also can. As long as it's a body. Then first thing you go to the center of mass. Draw W first. Then establish the axis. So what are the axes you have? Is it X or Y? Or you know that this one is collinear motion. So what axis you have? What axis you have? Huh? What should you write here? X or Y? What should you write here? Huh? YX? Again, what kind of motion you have here? Collinear. So what you should write? Where is tangent? Where is normal? This is what? Tangent, huh? This is normal. Okay. If you write X and Y, congratulations. This question totally, you 25 marks, you get 0 straight away. Because I don't need to mark already. The concept totally wrong. I don't need to mark already. I just write 0. Don't understand the concept, 0 marks. Okay. So it's tangent and normal. Your free body diagram is important. First thing we check your answer is free body diagram. Okay. Then the weight, then draw the angle, right? So datum is given on the top, right? So we use conservation of energy to solve the question, right? All right. Now, how do we know we can use conservation of energy and not the principle? Even though you use principle of work and energy, you still can do. But why we remove the work, the non-conservative work? Why? Why? Right. Before we start, I did give you the slides, right? What is conservative? What is non-conservative? Why we can remove? Why we can remove in the principle of work and energy is the energy 1 plus change of work equal to change of energy number 2. Why conservative, non-conservative work we can cancel in this case? Why? Even the question can ask you to use principle work and energy. Why in this case we can cancel non-conservative work component? Why? What force is non-conservative? I'll give you 3 examples, right, just now? 2 is conservative, 1 is non-conservative. The weight is conservative. Weight is conservative. Spring is conservative. There's one that is not conservative. Why is that? What is non-conservative? What is non-conservative? Huh? No, no. Since the beginning, I show you the slides. I even draw on a whiteboard here. I explain by this diagram. This is conservative. What is non-conservative? What is non-conservative? Friction. Why friction is non-conservative? Why? Why is non-conservative? You have to understand this one. If not, the following chapter you cannot do one. You're sure wrong. Okay, we are now at particles only. When you come to rigid body, you cannot differentiate what is conservative, what is non-conservative. You're going to be in trouble. You will be panicked, I tell you. Conservative, if the work of the force is independent of the path, depend only on force initial and final position on the path. Meaning we are not interested in path, then it's conservative. Okay. We classify the force is conservative. For example, the one I draw on the whiteboard here. The force drop from top to bottom. We doesn't care how the particle fly up or down. We only interested in the location number 1, location number 2. This is the work done by this force from position 1 to position 2. For example, the weight. Okay, you don't take weight multiply by the path distance travel. The red color, this one. Okay, spring also. It doesn't care how far the spring move back and forth, the total distance traveled by the spring. You're only interested in before the spring and after the spring. So that one is conservative. However, friction, you cannot ignore the path traveled by the force. No matter how it moves, friction always parallel to the path and it generate work. Okay, the greater the path, the greater the work. The keyword here is path. If your calculation, you need to calculate the path, that is non-conservative. That concept is important. You miss it, then you miss it already. Okay, we go back to the question. Okay. Why the principle of work energy, we can cancel non-conservative? Why we can take out the non-conservative? Why? Why? You understand what I explained just now, right? Conservative and non-conservative. Why we can take out the delta U or work, the non-conservative component. Why? Why? Huh? How you differentiate between the conservative and non-conservative? You look at the path, right? The force and the path. Any any anything that link with the path. Is there any force link with the path? Although there's no friction, yes lah, no friction. But is there any force component in your free body diagram that give you work? We're talking about path. What is the path of this object? How you draw the path of this object, this aircraft? This is the path. Any path, any force along this path? Is there any force along this path from your free body diagram? Does the question mention air resistance? No, right? Okay. Why weight is why weight is why weight is conservative? I'll show you the slide, right? Okay. You do not reflect on distance. We are not interested in what how the the path. The weight actually doesn't relate. Not cannot say relate. The work, it doesn't follow the path. The weight always pointing down, right? Yeah. Of course, with the angle, right? You can, of course, if you want to turn it, yeah, there's an angle of the aircraft here, but the angle always changing. It changed from 60 degree to 15 degree. Although you say, oh, sir, I can change this W into N direction and T direction. So there's a W along the T direction. But then why I do not say W is a non-conservative? It's a conservative. Okay, because this question we only interested in before and after. Position here. Position here. Okay, and there's no force go along this curve. There's no force that go always perpendicular to there's no friction force that go tangent to the curve. Okay. So you use conservation of energy. Conservation of energy in chapter 3, you only have two, kinetic energy and potential energy. Potential energy, you have two. One is mgh and spring. There's no spring here. Okay, unless the question change the cable into elastic cable, then you see the K constant for spring. Then you need to add spring here. Okay, So the rest you just substitute half mv square, position A. Why position A? Because this is before equal to after. Before mv m half mva. Yeah. So in your answer, if you write 1, I'll give you wrong. You write half mv1 square. Although I know that you are meaning the first position, but in the diagram given in the question, there's no 1 there. There's no number 1 there. So I'll be very particular in your writing. So notation, please write carefully when you read the question. Don't write 1 or 2 unless the question write 1, 2. Okay. So minus mgh. Why minus here? Why there is a minus energy for your potential? Why? 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 Why negative? Why negative? Why negative? Huh? No, why negative? It's not positive. Why mg? Huh? Why mgh negative? Why mgh negative? No. I mentioned something, right? Huh? Because what? Datum what? Datum over here. Your object where? Below. Your object below datum, you get negative mgh. Huh? Maybe I need to repeat 3 times for every slides because most of you don't understand simple slides. This one. I didn't mention in the class. mgh or potential energy, you are referring to datum. If your object fall on the datum, what is the potential energy? Huh? 0. If the question purposely put the datum on the object, your starting potential energy is 0. Don't go and suka go and put 1 value there. Then you don't understand what is mgh. Okay. In statics, we're not that tricky, but when it comes to engineering dynamics, will be very tricky to test your understanding, especially when it comes to datum. So when you put your object above datum before start, then you get positive mgh. On the datum, you get 0. Below datum, you get negative. So in your calculation, positive, negative is important because you're dealing with vector. Okay, you're dealing with vector, you're dealing with direction. Okay, so go back to the question. So same with B. B position, you have kinetics energy, half mv square. And potential energy, Y negative again. Why? Why negative? Below datum. Okay. So you put in all the parameter, convert accordingly. Okay. What I need to highlight is the A, velocity A is 0 from the question. H, how you find the H? You take 20. Where is your H? Your H is not here. Don't bring what you learn in statics into dynamics. Your static always start with ground. But in dynamics, you need to look carefully, especially question with datum. Don't stick to the static. You static always start from the ground. But engine dynamics, not necessarily start from the ground. It will start from a reference point, in this case, datum. So how to find the height, MGH? MGH is referring to datum, again, not ground. If you use this height, wrong already. You're referring to here, here to here. So how to find this height? You have 20. You draw a triangular. You have angle here, right? So all this, you can draw a line here. You can draw a line. You can draw a triangular here. Also can. Okay, either draw this one or this one. So if you use this one and this one, you're using cos. Okay, if you're using this side, you put to here lah. It's cos lah. Here the height cos. Right? Then when it comes to here, B is 15 degree. This one changed to 15 degree. So there's a triangular here. So the H is here. Sorry, H is from datum to here. Okay. So you have cos 15 degree. Okay. 16. You see the arrow? Here to here. Yeah. Trigonometry. 20 HA 60. Okay. Then this one reduced to 15 degree. So you get cos. Okay, important careless mistake here is the positive negative sign. Once you get datum, you need to be careful. Sometimes we very tricky, you pull the datum down to the object. We give you datum over here, then you will be confused already. If I pull the datum down, your MGH for A here will be 0. Straight away here 0. If I pull the datum down to the body of the aircraft here. Okay. Yeah. So if I pull the datum down, if I change the question, same, the question same, from 60 to 15. The H, you measure it from where? From here to here. Here to here. From the datum line to the object. Okay, so you need to take the height here. Okay. Okay, once you find VB, substitute the only one unknown, which is a VB here. Okay, one unknown, solve VB. He asks you what is the maximum tension in a cable. So you use equation of motion. F equal to ma. So split into normal and tangent direction. So F in normal direction, all the force, you have tangent, you have mg cos theta, and this is normal, right? Remember, there's an equation for acceleration normal, v squared over rho, that you learn in chapter 2. Don't say, Dr. Ang, I cannot find an answer. You learn in chapter 2 already. And collinear motion always tied up with A equal to AN plus AT. They always have two vector, normal and tangent direction. Okay? You substitute all the value, you get the tangent answer. The question asks you at 15 degrees, tension at 15 degrees. Tension at 60 degrees is another case, but the question asks you at theta equal to 15 degrees. So you just substitute the angle with so and so. So for your free body diagram, it will be safe if you replace this, the one that you see on the slide here, this 15 degree with theta, with a common parameter instead of numbers. Okay. Yeah, right. Now, important part is from the first line and second line. The rest is substitution. Okay. All right. Now, example number 9 is a killer question. Usually come out in final exam. Right. So this is a spring and mass. Every time you see spring, it will link with the energy and work. Work and energy. So ram air have a mass 100 kilogram from the top. Release from rest, you have a V1 or V from position 1, right? So you can label where is your first position, where is your second position in your free body diagram, right? You label 1, label 2, and so on. From rest, 0.75 meter on top of the spring. So before you start, they have a spring below. The distance is 0.75. With stiffness K, A there. If second spring is stay within the spring, so means you have an absorber, like a car absorber kind of principle. We have two springs. One is A spring, one is B spring. B spring is coil inside. So you have two spring system. Second spring have a stiffness so and so. If second spring having a stiffness Ka is nest in A. Sorry, this one should be B. Typo error. The stiffness K for B is 15 kilonewton per meter. Typo error over here. Right. Determine maximum displacement of A. Displacement of A needed to stop the downward motion of the ramp. So you will see this kind of question when you come out to work as a design engineer. You need to design a stopper for any conveyor system or a precision metal stamping or even a simple car lock and so on. Nowadays, we use a lot of spring. Okay. Even down to your phone, you insert your memory card, you push in, you see you will feel a spring effect. You insert card, it lock. You want to, how do you remove your SD card? You press in, right? You press and then you will bounce back. So there's a spring there. So this question is similar to this question. The unstressed length of each spring is indicated. So this is the initial length. A initial is 0.4, B is 0.3. The question asks you maximum displacements of A when you need to stop this ramp. So you need to link this object over here. So this one I tell you already start from rest and also rest. VB also 0. So VA 0, VB 0. V at here will be 0. So you have 0, 0. Basically, you need more equation to solve. Okay, the unstretched length is go. So how do you solve? Okay, so when you see spring is either chapter 2 or chapter 1 question, or chapter 3 question. Chapter 2, you deal with work. Chapter 3, you deal with energy. Okay. So you look at potential energy first, right? So there are only two energy that we learn in chapter 3, kinetic and potential. So potential energy, again, don't bring something you learned in statics. Engineering dynamics, you need datum when it comes to potential energy. So in this case, they don't give you datum. So you can start with your datum in your calculation. At the end, you still arrive at the same answer. So assume that the ram compress both spring when it comes to rest. So when it rests, you need to press on the A and B. If B do not press, it doesn't count. You need to consider B also pressing. Datum located at the center of gravity at its initial position, like what you see on the screen here. So you put in your datum yourself at the center of gravity or center of mass. So you mark at the center, then you draw datum. This one also, datum. So start from starting position, go to end position. Okay, you are given the mass there, mass 100 kilogram. So to be easy, don't substitute the value first. You just write W here. W means weight lah, right? Mg. Okay. Okay. Then when it press, right? When it press, okay, when it come to rest, so the distance between the ram and the object A is 7.5. This is initial, the initial distance. So when this one come down, this is initial. Come down to here, this is initial position. So when it come to stop, it must be pressing your spring A and touch spring B. Okay, so this line is initial position until here. Then it must be pressing SA. So SA move a certain distance. We don't know how much it move, but there is a distance. So we mark there is a position go down with this SA. Okay, then this one pressed down already. So SB initial is 0.3. Right? But how you find SB? SB you take SA minus 0.1 means here SA the length of SB is depending on how long the SA move minus the differences between these two. These two is 0.1. Okay. Right. Now, once we have all the parameters, then we start to solve using potential energy. Right. So we have solved with the datum. Now we have energy. Energy, we have two. Conservation for energy. Again, why we remove the non-conservative parts? Why? Why we move out? Why the principle of work and energy we simplify until conservation of energy? Why we take out the non-conservative component? Why? 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 Simple answer is you're not given friction coefficient. Friction coefficient. There's no friction there. Friction is not considered in this question. right? He did not give you friction between the slider here. So no, you don't need to consider the non-conservative parts. You simplified principle of work energy into conservation of energy equation. So energy before equal to energy after. So only two types of energy we consider: kinetic energy and potential energy. Potential energy we break in another two, which is what? mgh and spring. Okay, so kinetic is quite straightforward, half mv square. V1, V is potential energy. Potential energy we only consider two: gravity, datum, and spring. So mgh plus the potential, spring energy. Spring energy half kx squared. Okay, so before and after. Next is just substitute. Before all is zero. Before kinetic zero, doesn't move. Zero. Why potential now is zero? Huh? Body at the datum. Is that typo error, or can I write positive here? Why can I why I write negative minus zero? Can I write positive? Can I write positive? Can or cannot? Can Can okay. So because your kinetic is zero, not kinetic, potential is zero, no spring, so zero. Basically, you can write positive here. Okay. So second part, T2 is zero because it stopped already. So stop, no velocity, so zero. You only deal with potential energy. Potential energy, you don't need to be panicked. Potential energy only deal with two things: gravitational mgh and spring only. Two things. So you do the mgh minus mgh. Why minus? Because position is below datum. Then you deal with the spring. Spring, you have two springs, so you have two spring equation inside there. Half ks squared. So half ks squared. K given SA is already mentioned in your free body diagram, right? Then KB also same. We already derived the KB distance. Substitute all the value, you should able to find maximum displacement, which is your SA. Okay, you have all the unknown there already. Okay, so you substitute, you check the answer. Okay, here, what I need to highlight is that this one you have a quadratic equation. Quadratic, you have positive, negative root, or positive, negative solution. Why we pick this value and not another value? You have to be sure you'll get positive and negative value. And we choose this one. Okay, go home and check why we choose this one and not another one. This is a quadratic equation. You have two possible answers. Why we choose this one? Go home and think. Okay, start to train your mind before you come to final exam. Final exam only you come and think, too late already. Okay. So once we have the SA, you can calculate your SP. Okay, you can calculate your SP. Okay. Okay. Okay, so this one you go and read lah. I even give you the answer that the question I asked you in the class just now. Why we cannot take the second route? Go and read. Okay, with this, we conclude chapter 3. Okay, we have 5 minutes breaks. We continue chapter 4, 9:05.